Yeah, I'm going to talk about a relatively new project that we've embarked upon in the last 6 or 7 months called Robius. The goal is to bring seamless and immersive multi-platform app development to Rust as a purely native Rust project. So at a glance, this project aims to, like I said, create a multi-platform app dev experience entirely in Rust such that developers can leverage all the great features of Rust that you know and love: robust ecosystem, safety, performance. The developers wouldn't have to deal with multiple languages or different environments, as is common with these bridged approaches, or you're bridging to Flutter or something like that. And ideally, they would never have to write a single line of platform-specific code, though they could if they wish to, but it wouldn't be required by default. Sort of a second sub-goal here is that we want to make mobile a first-class concern in the Rust community. I think over the past 6-7 years since, well, I guess it's 9 years since Rust 1.0 had become stable, mobile has sort of drifted behind embedded and systems programming use cases, so we want to elevate that to sort of a first-class citizen. A little bit of a background here. So Project Robius is fully open source. It's decentralized. We have collaborators across North America, South America, Europe, even Australia, New Zealand, and China. We try to keep all of the projects, the individual parts under this large umbrella, somewhat independent, and we let the communities drive each one of those. So I'll talk more a little bit about that later. But as I said, everything's entirely written in Rust. So why do we need a project like this? Like, what's the main motivation behind this? There's already a lot of great Rust UI toolkits out there. You're probably familiar with many of these. You saw demos from Makepad by Rick yesterday. And all of these other projects have done a great job of bringing a relatively nice UI experience to Rust. But there's a lot more to developing an app that has immersive features and leverages the platform nicely and robustly than just drawing UI widgets. Because of that, a lot of existing Rust apps, for example, Signal, the Signal Secure Messenger, an app commonly referenced as a major Rust project, actually has a lot less Rust than you would think. There's sort of a Rust core, and then all of the platform-specific stuff for each platform, Android, iOS, desktop, Electron, are still using those native things. So there's not as much Rust as you would think. So let's dive a little bit more into the motivation behind this. So I think everyone who frequents the Rust subreddit or Hacker News or any kind of Rust forums has frequently seen posts like I'll show in a minute where app devs are expressing a desire to use Rust, either front-end devs who already are familiar with other app toolkits or Rust devs who want to experiment with front-end dev, but they're not sure how and where to start because of all those offerings I mentioned before. It's a little unclear which ones you use, and these projects are independent, which is a good thing, but it's not always clear how to integrate them together into a functional toolkit, something as powerful and integrated as Flutter. There's obvious business advantages. These are the same as Flutter and any multi-platform app dev toolkit like React Native. You get that nice, consistent experience for both the developers and the customers, and you get to avoid the redundant development effort of tinkering with multiple different platforms. And of course, as we all know, Rust is great. I don't need to spend too much more time emphasizing this for this crowd, but we get these traits here, which is super nice, no pun intended. Right, so our goal here is to attract front-end developers to the world of Rust and then also allow existing Rust experts to experiment with front-end dev and maybe develop an app of their own. So these are some of the posts that I was talking about. There's just sort of an endless amount, all right? So if you've seen these, you're probably getting a little bit tired of these, especially if you are a UI dev, right? So you're saying, okay, that's not great. So as I already mentioned, there are a variety of Rust apps, but they typically suffer from platform-related pain points. So I mentioned the example of Signal already. So it sort of looks like this with the main Signal business logic written in Rust in this lib. Oh, you can't see my cursor. Oh, you can. In this lib Signal here. And then on each platform, it's whatever is the native wrappers, the native UI dev toolkit wrapped around this lib Signal. So because of this, you have to maintain a bunch of different projects, which makes it hard. You don't have that nice luxury of a single code base, which is what we're aiming to do. So on iOS, Signal has an additional almost 500,000 lines of code. That's in Swift and Objective-C. On Android, 1/3 and on desktop, because it's Electron, 250,000, but still, that's a pretty significant per platform effort. So I can probably skip this stuff about Rust. We all know Rust is great. It's most wanted. and we get these nice features, right? Okay, so I'm anxious to get to demos, so I'll skip through this stuff. But I do want to highlight a couple of motivating shortcomings from Rust, from a UI standpoint. So a lot of app developers and UI developers typically are expecting this familiar object-oriented programming patterns where one widget can inherit from another widget. So that's something that's a little difficult to accommodate in Rust. But many of these UI toolkits have developed DSLs specifically for that to get around that problem. Another frequent complaint we hear is it's hard to realize and deal with shared mutable state where you have multiple different UI entities all trying to share and mutate some data. So this results in this sort of closure-based callback pattern, which some UI toolkits have avoided, some have emphasized. It can be good or bad, it depends on your viewpoint, but there's a little bit of a schism there. And then, of course, everyone's classic complaint about the Rust compiler being slow, which, again, I don't necessarily disagree with. I don't necessarily agree with because we often give it too much work to do, but folks like Nick are working on that every day. One other potential problem, which I think is relevant to what Sophia just talked about, there's potentially a very steep learning curve for front-end devs who are used to something like Java or React Native's nice syntax. Rust can be a little bit of a thorn in their side. So there was a nice survey from a consultancy venture called Very Good Ventures where they found that mobile developers needed around 3.5 months of retraining to switch to Flutter. So that could actually be worse for Rust. So our goals are to kind of address some of these motivating challenges and see if we can make things a little bit easier. I'll just talk about some goals. The first one is we want to sort of create a reference design of the full system stack where we have all of these independent projects all coming together in a way that is known to work and can just be grabbed and used immediately by a developer who wishes to create an app in Rust. I'll talk more about this later, so we don't need to go into the details just yet. We also want to establish and publish some proof of concept demo apps, not just simple ones where you can see how to do something like, recreate eBay or a Taobao style e-shopping app, but also more like commercial or mainstream grade flagship apps. For example, I'm working on a Matrix client, and I'll demo a imitation of LM Studio that other folks in our team have worked on. The general meta goal here is that we want to make everything easy for a new developer to fork and quickly modify with nice code, well-structured code, and great documentation. Obviously, easier said than done. So some of the technical goals, I'll just go over them real quick. We have things split into build time and developer tools, and then runtime behavior. I'll just talk about two real quickly. So quick compilation I already touched on. As you saw with Makepad, and if you've seen presentations by Dioxys and other folks, a lot of these Rust UI toolkits combat this slow compilation with live reloading of the DSL elements, which allows you to just quickly change styles and things like that without recompiling Rust. So that's great. Another thing we can do is establish a structure of many small crates, which actually happens to align very well with the sort of decentralized, community-driven individual components. We get the benefit of parallel compilation, and we also strive to minimize dependencies such that we're not compiling a bunch of unnecessary things. I think Rick touched on that a lot yesterday, so I won't go into too much more detail. And then if we can't get all of this, at least we want to make incremental compilation very fast. And then, of course, I already briefly mentioned consistency across multiple platforms. This is sort of our key principle. We don't ever want developers to have to touch platform-specific code, but it shouldn't be too hard for them if they wish to do that. And also, we want to impose the bare minimum of overhead. Okay, so let's get on to some significant challenges. So as you can imagine, a project like this is a multi-year endeavor. And one of the most difficult parts, I think, is how to deal with and abstract all these widely varying platform APIs and OS services provided by the underlying platform. Like even on mobile, just Android and iOS are significantly different. And that doesn't even bring in the complications of the various desktop platforms. We need to handle very complex build procedures where we're not just compiling Rust, which may itself result in compiling platform native code like C or Java, but we also need to support these platform-specific toolchains, linking conventions, and then things that Cargo doesn't necessarily support, like arbitrary post-compilation steps. Then, if you want to actually publish an app and distribute it on the App Store or a package manager on Linux or something like that, you need to generally assign, bundle, and package it properly And in some cases, this is actually required to even get basic features to work, like displaying system notifications on Apple platforms. So the real challenge here is doing all of this in a somewhat consistent way across widely disparate platforms. We also have a variety of other challenges that we're tackling. One thing is dealing with mixed forms of concurrency, where you have UI threads and some platform APIs that UI workloads and platform APIs that only want to run on the main thread. Otherwise, they throw an error or they just don't display anything. And then some APIs, for example, from an SDK like the Matrix SDK, typically require you to use async, whereas some other system APIs don't allow. They don't offer any async capability. So this is something that throws a wrench into our plans. And then, of course, we also want to support multiple different UI toolkits, right? So a lot of our work so far has been focused on Makepad because I think that presents one of the more difficult UI toolkits to deal with because everything is done from scratch natively. So if we can do it for that, I figure we'll be able to apply these other these platform crates and various features to other UI toolkits like Dioxys with relative ease. Okay, so we also have a joint white paper coming out, which Nico Burns is organizing, and it will be sort of covering the state of Rust GUI systems and the challenges therein and what we plan to do with that. So look for that sometime in the summer, TBD. Okay, so let's get into some specifics of what Robius actually comprises. So we have a pretty diverse community of various projects. So the Robius project itself is sort of just an umbrella that deals with the overall integration and basic app dev concepts. I myself am working on that as well as platform feature abstraction crates across different platforms. The Osiris project is run by David Reinsberg. I think he's here somewhere, but he also gave a talk on Monday if you were there at the GOSM. But this is the project that deals with signing, bundling, packaging, and distribution of apps, dealing with how to wrap cargo properly for that, and then also some wrappers around the lowest level OS services on each platform. We have a meta build project called Quake Build, which is similar in concept to Make, runs on top of the lovely new shell that Sophia has worked on. And this is developed by Cassandra. I'm not sure if she's here. But this is a really cool up-and-coming pure Rust build project that we hope to use to drive the top-level build procedures that will actually call Rust. And then there are some other projects I already mentioned, like Concurrency and dealing with the mixed forms of async and UI main thread stuff, as well as how to properly cache widgets when you're populating and drawing data that may be expensive to do. We hope to target, we are targeting, but we hope to target more of these UI toolkits. Our collaboration with them varies based on the project. With Makepad, I work with Rick Daly to request features and drive development there and make contributions back to Makepad when possible. I aim to start doing that for Dioxys as well, but for our platform-specific feature abstraction crates, I have targeted Dioxys in some of these cases, which on mobile, it generally uses the same infrastructure as the Tower project, the RAI backend. And then we've begun some very light periodic exchange of ideas with the Linebender project. So we hope to make this flourish more in the future, but that's kind of where we stand with all of the different projects involved in this. So in terms of a philosophy, we generally want to stay out of the UI's way. I'm not a UI person. I don't want to deal with that stuff. I want to let those experts do what they do best and just fill in all the other gaps here, right? So like the concurrency management, platform abstractions, and all these nice little features that you need just beyond the UI. So these are sort of passive libraries that will allow any app logic or UI logic to drive these platform features and access them in a somewhat consistent manner. So I have an app called Robrix, which is a Matrix chat client, and in the future we'll make it do more things. But if you were to kind of overlay the architecture of a complicated app on top of that reference diagram, it would look something like this, where you have a bunch of different features. And I can show another diagram later about how we deal with the concurrency challenge. But let me just say there's quite a lot of different platform abstractions that we're targeting. You can also consider some of these OS services. It's all the things that are local to a system. I'm not talking about like accessing the Google Maps backend or something, right? So things like notifications, drag and drop, rich clipboard, Makepad, and some other UI toolkits, like the ones that use Winit, they support this to some extent. But there's a lot of other things that many of them haven't dealt with because that's not, I think to be fair, it's not really under the realm of UI toolkit development. So things like accessing your location, dealing with connectivity management, sensor access, these sort of things. So there's quite a lot to do, and as I said, this is a relatively new project, so we're just getting started, but this is kind of where we're at right now. Orange are things that are in progress, green are things that are done, and I should also say that we aim to reuse projects from the existing community already. So for example, the Tori project has worked hard on a lot of nice utilities for desktop, so we can use like the Muda crate, MUDA, for the menu bar on desktop. We don't need to, re-implement everything ourselves just for the sake of doing it. Our philosophy when implementing these platform abstraction crates is just to be as close to native as possible with a bare minimum of overhead, and try to minimize the set of dependencies that we use, that we require, rather, for each one of these platform abstractions. So a good example of this is if you're communicating with some platform API on iOS and you need to provide a callback, I think that's an Objective-C block, right? You would think that you want to do that in an async manner, but so what you might initially do is to use Tokyo's like one-shot async channels to communicate the result of that back to the main thread. But in a lot of these cases, adding Tokyo can, triple or quadruple your compile time if you have a very small Makepad app, as we saw yesterday. So we're trying to avoid these as much as possible, or just make them optional when desired. We have quite a few platforms that we're targeting. I think this overlaps with many of the UI toolkits, since we obviously need them to support these first. The ones in green are, I think, our major platforms that I've tested our apps with, and the ones that we test most frequently. In the future, we want to integrate with OpenHarmony and the Oniro project, which is a sort of a European distribution of OpenHarmony, and also web. I haven't spent a great deal of time on that, but some folks in the community have. And then there's some others that we could potentially talk about later, but that's where we stand now. Okay, so that was a lot of boring, I think, boilerplate. So let's get to some cool demos. Here we go, or hopefully cool. So here is my Matrix client. Can we all see that? Cool, yeah. Somewhat basic, but this is written in Makepad, and here, hopefully internet's all working. Yeah, so the performance is great. You can see we're using platform-specific features when required. One thing that I wanted to highlight, just because Rick didn't talk about this yesterday, is rich text formatting. So that was actually somewhat of an adventure that we went on for a few months. I know that Rick loves to show off some really cool demos, like here's a fractal that I can run on an Apple TV, but I was like, that's great. Can we please display bold italic text? So took longer than you think, but yeah. So we're kind of the, I guess, practical side of things compared to the eccentric genius of the rest of the Makepad crew. So we were asking for things, just like displaying block text and things like that. So you can see this is mostly to Makepad's credit. Their performance is really good. It's nice and fast. Hopefully that's coming through on the projector. On my screen, it's gorgeous. And a lot of this stuff is, provided by Makepad, but we also do have a few things that we've integrated into this, like opening links and URIs, sort of like a share sheet on mobile, and authentication for things like accessing encrypted rooms. So I can give you demos of that too. Hopefully this works. So this is the exact same app, same code base, 100% the same, no platform-specific code. Run it on Android. Okay, yeah, I don't know what happened to the text. It's very strange. Well, it doesn't normally look like that on an actual device, but the same sort of thing. Everything's nice. Generally working, so I'm relieved that that's working. But yeah, this is a single code base, no platform-specific code. And right now it's a very mobile-oriented UI, but in the future we plan to make it a little bit more of a responsive UI with different types of viewing panes, like a multi-pane, sort of like your IDE for different rooms simultaneously, and then integrating some LLMs, like AI features into the Matrix chat experience. I talked about some of this on my talk on Monday, but I can give a brief demo of another project. So this, can we see this? Make it bigger. Okay, yeah. So I did not write this app, but this is another app written in Makepad that uses some Robius components, written by the folks from YWorks, who are working with us, Julian and Jorge, wherever they are. So this is effectively a implementation of LM Studio. I don't know if anyone has used that here, but it allows you to download models, local to your large language models, locally and run them, and you can experiment with them and do cool things like chat. So We're using the WASM-Edge backend to run locally on my machine, these models within a WASM environment. And as you can see, some of our rich text formatting has also paid off here. So I can talk to it and say, hi, tell me the coolest 5 cities in the Netherlands. And this is all running locally, so hopefully it gives me a list. Okay, there you go. Yeah. So anyway, you can see how something like this would be nice to implement across multiple platforms. This currently only targets desktop, but we could also run it on mobile, assuming that we could run the local LLMs well. And we plan to sort of incorporate this and the Matrix app together such that you can do something like talk to the local LLM instance within your Matrix chat context and feed it all the local room data that you have, which doesn't jeopardize end-to-end encryption or your ownership of your data sovereignty. So anyway, yeah, this is a very sleek app. So this, I think, serves more as a Makepad demo rather than anything else. But you can see it's quite feasible to develop nice, seamless application experiences, across multiple different platforms. So some other things that we've been working on are, as you may expect, some of these platforms require a little bit more effort to support than others. For example, on Android, we frequently have to build small Java class files such that we can, pass, for example, a callback to a platform interface and be notified when it completes. So a good example of that is authentication. So I can give a quick demo of that. Oh, this is very small. Okay. Yeah. Where are we? So this is just a very simple testing application. I don't know if it's been built, but it should be relatively fast. Okay. So while that's building, I can show the same application on Android. And this is just a sort of a testing application. Yeah, so this is an older version, but here we have a couple of just platform features that we're testing, something like authentication. So this works seamlessly across all the platforms, as I'll show in a second here. So this is just a basic authentication prompt. I'll run the wrong finger through, it's not going to work. Run the right finger through, and you can see it worked. So that's nice to have. The developer who calls this, I can show you the code. It's very, very simple. You basically just define a policy and call authenticate with a message. So if we cancel it, you can see you get the result that the user chose to cancel it. Similarly, we can test a different crate, which is called Robius Open, which provides opening files or sharing files within our app, opening URIs, things like the share sheet. So we can do something like call myself. Oh, I have this strange bug where I can't use the shift button. There we go. Okay. And that should just work, albeit slowly. Okay, there we go. And similarly, you can, do the same thing with a different URI. I don't think this is too wildly exciting, but, just to prove that it works. There you go. My MacBook is not a top-of-the-line MacBook, so it's struggling. There we go. Okay. So yeah, I can run. So in the meantime, we've built the same exact app for macOS natively. And as you would expect, it does the same thing. I am trying to steal your data, authenticate, and you get the expected platform native authentication prompt that you want. So I can use my Touch ID and it worked, right? Or cancel it and you get everything you expect, right? Similarly, I can call myself. I think it's going to open up FaceTime. I'm not sure what my default dialer is. Yeah, there you go. And everything works as expected. So this is really nice to use. From a code perspective, it's quite small. Oh, dear. Okay. All right. I guess it updated silently. Gotta love that. Right. So the code is quite, oh my God. Apologies. The code is quite simple for doing these sort of things. So this is, again, Makepad app. In this case, we're basically just querying whether or not we pressed enter on the open field for the entering the URI, or we click the button, and then all you're doing is literally just calling a single line, right? So the platform APIs can be made very simple with these nice crates. So that's kind of our goal here. Authentication is a little bit more complicated, but still relatively simple, right? You're setting a policy, thank you. And then in this case, we're doing it in a blocking fashion because it comes from the main thread, and we want to not allow any additional activity until that happens. But we also have a non-blocking version that uses async under the hood. And you can see it's just a few lines of code to make this work. So here in this entire app and in Robrix, there's not a single line of platform-specific code, which is really nice from a development perspective. And we have a series of other crates, let me continue here, that are sort of the infrastructure to make this happen. So just like you have the CCRS crate for building native C and C++ code from a Java cargo build script, we can do the same thing for Android. So I wrote this little crate Android build that does that. And then we have another abstraction of sort of the environment that the UI toolkit owns. For example, on Android, that would be something like the Java VM, the JNI environment, and the current activity being displayed. So these are things that we need for accessing particular platform-specific APIs, and we've sort of wrapped them up in these nice little wrappers that can be composed currently through Makepad, but also in the near future with the Dioxys app or other Winit-based UIs. Okay, so that's what I demoed. Right, so just to really hammer the point home, I don't have all these platforms with me, but this is the same Robrix app running on iOS, Linux, Windows, macOS, and Android, as you saw locally. So that's nice. I also wanted to highlight that this is a relatively efficient stack because in this particular case, we're not using a web engine. So the Makepad version of Robrix, the Matrix chat client that I just showed, is around 170 megabytes of memory usage, a third of which is fonts and a third of which is frame buffer. So it's our goal to begin using native fonts. But to compare that to something a little heavier, like the Element app, which runs on Electron, you can see it's roughly 3 to 4 times the memory usage. And this is also with very aggressive caching of UI elements and UI data population workloads that I have made no effort to improve yet. So how much time do I have? We go until 10:50? Okay, yeah. You say 5 minutes? Okay, great. So I do have time to go through one small challenge that kind of motivates another project within Robius, which is dealing with mixed forms of concurrency. I alluded to that before, but let's go over it in a little bit more detail here. So this here is the draw flow for displaying that view of messages that you saw. Where's my element, right? So that draw function is called every time that you're viewing a different message here, right? So this is the particular, This is the particular code flow for drawing an image that comes in as a message. And what you would typically see from what I would assume a relatively naive app developer using this framework would do is attempt to call, again, this is on the main UI thread, a convenient matrix client function that retrieves the media for you, right, based on this URI, and then will deliver you the data as just a string of an array of bytes. The problem with this, as I'm sure many of you Rust experts can tell, is we haven't done this. This is an async function. We haven't called this within an async context. So that's not going to work. So you say, okay, that's easy. I'll just wrap it in an async context, and I'll spawn it onto an async task using something like the current Tokyo handle. However, this is the UI main thread, and we don't have any async context. This thread has not been attached to a Tokyo runtime. So you're going to get a runtime error this time. So you made it past compilation, but you're not getting runtime. So I think this highlights one particular issue that is a perennial problem in UI toolkits, which is the obvious one is that you must not block the main thread, right? So if you invoke a blocking regular synchronous function from the main thread, obviously that will hang the UI, especially because it's a system call in which the OS could put the thread to sleep if it needs to. I think less obvious is that in general, you shouldn't also call async functions on the main thread because those could also block it. So this depends greatly on what your async executor is doing, but it is possible such that a native thread could be blocked while the executor is polling whatever futures are being awaited. And what I mean by that is that the main UI thread its time slice would be used by the async executor rather than the UI toolkit, which they generally expect full control over that thread, right? You can have the same problem on background threads, but it's not really an issue because those aren't blocking the UI. So the key point here is, in our opinion, we shouldn't invoke any blocking functions, even async ones, on the main UI thread. So that causes, I think, a lot of difficulty because now you have to deal with multiple forms of concurrency. So The immediate solution that we have for this is sort of an ad hoc one specifically for this. We're fetching media here, which is inherently an asynchronous operation. It could block, and it could take a long time. So I created a sort of a media cache with a function that is aware of this possibility. It's non-blocking. It will submit a request here. Should be the code. Okay, that's a slow animation. Right, so here's the code of that, which will basically just submit an async request via another thread that runs in the background with async context, meaning it's attached to a Tokyo runtime. Right. So we're using a variety of queues and channels to make this happen. But once this happens, so this is the enum variant request that we send over. And in the background thread, we've run one of multiple async workers, which is an async task here, that will then correctly and properly be able to invoke this async block where we can actually await on this future that the Matrix SDK provides. And then once it's completed, we can update the media cache. And then the next time around that you got that try media call, let me see this one. The next time that you call this, that entry will have been populated and you can very quickly get the image data and display it. So what this looks like, oh yeah, we do use this pattern for a lot of different things, sending messages to, paginning in the timeline, loading earlier messages. What this generally looks like is quite a complex web of channels, queues, and various forms of inter-thread communication across all these different categories of threads. So we have a standard synchronous to synchronous channel, like what you'd get in STD MPSC, between the main thread, which is a standard thread, and the background thread. And then we have sort of, non-heterogeneous channels, I'm not sure what to call them, in which one side is async and the other side is synchronous. It depends on who is receiving the request and who is sending the response. So this is exactly what I showed previously. And with the media cache, you're accessing this via shared memory rather than specific channels, but it's the same issue. So dealing with this, I think, is a massive headache. And this is one thing that motivates us to come up with some sort of maybe proc macro-based solution or something where a developer would be able to say, hey, I have this async function. I want you to run it for me. When I have the result, just give it back to me next time I need it on the UI. Thanks. So I don't yet have a fully formed solution for this, but this is another thing that I think falls under the domain of a project like Robius. So hopefully we'll post a cool solution to this in the future. Okay, so I'm out of time here, but I just wanted to say a few things before we wrap up. This is a new project. I've been working on this maybe for 6 or 7 months. A lot of that was contributing back to Makepad and shoring it up and, aggravating Rick as much as possible. But we have a lot of challenges remaining. So we're always looking for help and contributors. We do work closely with these UI toolkits, and I hope to use this conference to, communicate with more of them and work even closer in an ongoing manner. Our roadmap for the rest of the year is to continue developing more of these key platform feature crates. We have about 3 or 4 right now. I demoed 2. But there's like a series of 9 or 10 key platform features that we want to have before we can, really publish an immersive app like that Robrix Matrix client. Speaking of, we do want to actually publish those to the App Store to show that this pure Rust app dev experience can result in an app that is actually usable and publishable on app stores and package managers. And then I also want to create some really nice documentation, like guided walkthroughs on how to write an app like Robrix from zero to completion. Finally, I just want to thank all the folks who are working on various parts of this project, the Makepad team, Jonathan from Dioxys, some of my colleagues at FutureWave, the Yworks folks, and other people working on various aspects of this. Without them, it definitely would not have been possible to show off all this cool work. And with that, I'm more than happy to take any questions. Feel free to reach out here on my various socials and check us out on Matrix as well. Thanks.
I see a question over there.
Yeah, thanks. Really nice project. I was wondering, compared to Flutter, where you can also do mobile apps, you can also do browser apps with Canvas. Is something similar possible with Robius or in the works?
Yeah, so as I mentioned, web was one of the targeted platforms. I have not spent a great deal on that personally, but I know Makepad and Dioxys and other UI toolkits have. So not everything can currently target WASM. There are some hiccups, for example, in the Matrix SDK. That's why I didn't show an example of Robrix running on the web. But, those can be ironed out. We do intend to support web as a full target platform. I think it lags behind desktop and mobile a little bit right now, but that also depends on the nature of what your app is doing. But yeah, it will be targeted in the future. It's a little bit incomplete now.
I see one there. Oh, wait a minute.
Oh, 1 second. Yeah.
So for the various platform feature creates for those are for things like gesture recognition and like authentication and so on.
Sure.
Yeah. Are there plans to make sure that Winit and Winit based GUI frameworks and so on can consume these easily?
Yes. So that's the goal. They would be usable with very minimal configuration from the app dev side, with a variety of UI toolkits. So as I mentioned, currently we've spent most of our time focusing on Makepad compatibility, but I also have Dioxys support in mind, which I think will also natively support Tauri since they build on the same frameworks. With Winit, I know that the line bender folks are working on that, and I have discussions with them, but I'm not an expert in that, so I'm not exactly sure how hard or easy it will be to neatly interface with Winit. But yes, I would like to.
Excellent. This is something. So I'm from Bevy, and this is something that a lot of our users making games really want. Is they want better access to the platform abstractions, especially on mobile, where they don't want to go and constantly write gesture recognition code or set up like in-app payments or figure out how to integrate with like motion controls and so on. So this is really good to hear.
Yeah, I would love to talk about Bevy support as well. I know the least amount about that as a platform compared to the other ones.
Awesome.
But that was on one of our original, I think, slides from last year's GoSim. So I do have Bevy in mind as well. It's just there's so many things to support,
Absolutely. Yeah, I'll talk to you later.
Yeah, thanks.
Okay, I cannot do that.
Hi, thank you. My question is about the native API. So where do you hook your FFI, let's call it a bridge? Do you hook it like on the layer of Swift and Java? Or do you hook it in the layer of C and C++? So let's pick example, the Bluetooth. There is the native API, C and C++, like low layer of a driver. And there is the one that is provided by Apple and Google. Where do you hook your...
Yeah, so it's going to be dependent on the particular feature. So for authentication, we do it at the Java layer on Android, and then on iOS and macOS, it's done at the Objective-C layer. So there's no Swift UI usage from our Rust crate. But that's not to say that we wouldn't do that in the future. I think it really just depends on, for that particular feature, what is considered to be the most canonical standard way by the platform to access it. Publishing an app to a lot of these app stores and package managers, they have very specific restrictions on what you can and can't do. So we don't want to, do something weird like remove all Java usage or, kind of go to some hacky interface that isn't considered a public API provided and endorsed by that platform. So the answer is it depends, but generally what you would typically use if you were writing a native app on that platform via their SDK.
Please.
Nice project. A bit of attention about your media loading example. You say blocking with futures is a problem in the UI thread, but couldn't you just consume the future itself because your media type is effectively not done of pending and some?
Yeah, sure. So I admit that was a bit of a contrived example in the sense that you can easily get around this, but I think it shows. So in this particular case, I can provide a bit of background context, which was that the previous apps that had been developed with Makepad were, just using sample data or, test data, and they weren't really grabbing things from like an official backend server like a real Matrix client would or a real, general app would with their own SDK. So this is the first time where we integrated something like that into a framework that previously fully expected only synchronous function calls, right? So there was no async usage really. So in this case, yeah, there are many other solutions we could explore. I merely went over that example to highlight, I think, what will be a common pattern when developers first start to use one of these UI toolkits and want to integrate something a little bit more complex. But obviously it depends. If you have like a web engine one, it's highly likely that you already have a lot more access to different features underneath the platform. That's why I said Makepad is one example that presents, I think, the most challenging project structure, simply because everything's done in our own native manner, and we're not relying on underlying web engines or something like that. But yeah, there's definitely many other solutions to that. I think it just highlights a case of where a project like Robius could step in and provide a more ergonomic way to deal with something like mixed concurrency. Yeah.
Thank you.
A final question. Does anyone have one? Okay, I see a hand there in the back.
Yeah, not a question, just a comment on the async stuff, because, that's also part of the Makepad architecture. The reason that we haven't done any async yet is because I feel that it's maybe an extension feature. And yeah, there's many solutions, as Kevin said. We do have an async executor that is single-threaded that we could use for that, but I found that if you use async, you start to have to wrap your data in RCRF cells, or you gotta do the borrowing runtime. So we chose to go, okay, let's stay very simple and keep the async as a sort of an add-on if you really need async flow. But it's definitely a work in progress, because I don't think this is a particularly pretty way to solve it. Yeah, if you have ideas here, I'm open to the suggestions as well. So.
Okay, so give a big hand of applause to Kevin.
Thank you. Appreciate it.